This question is asking in an inclined pipe about 60 degree, if you fill this pipe with water, how much pressure it will develop at the bottom of the tank. So what you have to do here, doesn't matter how long the pipe is, you have to see what's the elevation of that point from the ground. So we need to find out that height, h, which is simply 200 times sine 60 degree. If you do that calculation, you find this height is 173 approximately foot of water. If this is filled with water, how much is the water pressure? So this would be pressure head. If you express this in terms of head, this approximately 173 foot of water. And then the second question is asking, convert that to PSI, pound per square inch. We have discussed that pressure head and how the equations P equal to gamma H is developed. So check that video. In this case here, gamma is the water gamma, which is 62.4 pound per feet cube. And then the height of the liquid is 173. To be exact, is 173.2 foot. Will not make a huge difference because it's a very large number. Now we have foot cube here and then foot right here. So I'll have foot square left here. So I'll have to convert this pound per foot square. So this will come in 62.4 times 173.2. So 1 foot will cancel. I will have pound per foot square. And then the foot square I will cancel to inches. 1 foot to 12 inch. And then whole square that. If you solve this, everything is going to come approximately 75 psi at the bottom of the tank. So that is the answer to this question. And it is asked, next question is asking, what did you calculate? It is gas pressure or absolute pressure. Everything is Mars in the air. So if it doesn't say anything, usually it is gas pressure. So everything is Mars inside the air. So at this point, also at this point, we have 10 miles of air sitting on top of us, pressurizing. So actually ignoring that air pressure that existing basically everywhere. So this is the gas pressure that you calculated. And then if you calculate that, convert that gas pressure to the absolute pressure, they simply you add the 14.7 psi absolute, the atmospheric pressure coming from the air on top of us. Air has weight, and this is 14.7 is actually developed because of that. There is a video on that, how this 14.7 is actually developed coming from the air on top of us. So basically the absolute pressure would be simply add these two number, which is 86.7. Well, no, so that's going to be 9 actually. 89.7 psi absolute pressure. And then the next question, number 4, is asking, if you have a leak at the bottom of the tank, what would be the velocity of the flow? The total energy store here, if it's you can see mgh, that's the potential energy store right here. And this is the ground, then everything here will come, if there is any leak, everything will come out as a half mv square kinetic energy. So if you simply set that equation, half mv square is equal to mgh. So mass will cancel from either side. So v will be equal to square root of 2 gh. And simply you plug the numbers here. G is 32.2 foot per second square. H is 173. Then the velocity I calculated, v is equal to 105.6 foot per second. If you put that in, convert that into mile, 105 foot per second. So 5280 foot is 1 mile. And then 60 second is 1 minute. 60 minutes is 1 hour. So if you convert this many seconds is actually 1 hour. So if you put it in miles per hour, convert it, it's going to be 72 approximately miles per hour speed, which is pretty large. The last question is asking what's the, instead of water, if you express this using, if you measure this using a mercury barometer, which mercury is the one of the, it is the heaviest liquid on earth. So then it's about 13.6 times heavier than water. So what's going to be the pressure head? Simply you divide that 173 by this mercury specific gravity. So that will provide you approximately 12.4 feet of mercury. The answer to the last question.